Who can tell me what the parent function is? Yes, sir. It is the square root of x. That's one of the 5 parents I had you draw, and that's what you should have been looking at in your notes. Those 5 things I had you draw. That's something you're going to need to know. Okay, part B. What are the horizontal and vertical shifts going on here? You can just describe them to me in words right now. Looks like right 2, up 1. Yeah, right 2, up 1. Very good. The tricky part. Who can tell me what you think an equation for this might be? No? Yes, sir. Everything's right except for one little thing. Minus 2. When it comes to horizontal shifts, they're kind of flipped because you have to think, what's going to make this equal to 0? It's positive 2, hence the right shift. Now, very good, very impressive. Even if on the day, let's say on test day, I give you an actual equation and it looks like this, okay, and I ask you to graph it. Well, you remember most of the stuff, but you don't feel confident graphing it yet. Something you can still do is still find where it's going to make the inside of the function equal 0, which is 2. And then make an xy chart centered at that value. That's always an option all year. Take the value to start with, and then start an xy chart and go in both directions. Of course, this one has nothing in the other direction. And it'll always be wherever what is inside the function equals 0, that's where you want to start from. Any questions? Excellent. Excellent, excellent, excellent. Yeah, we're just gonna keep going. Today we're picking up with 1.7 where we picked off. We'll call it 1.7 part 2. 1.7 part 2. I'm just gonna sprint through the first few slides just so that help you remember back to what we did on Friday. Remember we were talking about domains of functions. We looked at denominators. We looked at radicals. We looked at combinations of the two. We just found everything that would not work in a function and threw that out of its domain. Today, we're going to keep doing things like that with functions. But we're going to start actually by putting multiple functions together. Now, if you read the directions, in exercise 31 through 48, we're going to add, subtract, multiply, and divide the 2 functions they give you. Believe it or not, those aren't actually very hard. Let's look at the first one, which apparently, I don't know why, I cut the numbers off of all of these. So we're going to call this one 31. Let's look at number 31. When you add and subtract functions, it's literally like terms. That's it. You take f of x plus g of x, and it looks like first we are adding. So what are my like terms here? 3, yeah, x. So 2x plus 1x, 3x. 3 plus a negative 1 is 2. So this is f plus g of x. Or, I don't know if I wrote that right, but yeah. That's f plus g of x. We just literally add them together. When you subtract them, same exact thing, except you put a minus sign in here. So here we go. F minus g. 2x minus x, 1x, 3 minus a negative 1, which is plus 1, so x plus 4 would be f minus g. Questions on just those 2 steps before we go any further? Important. I noticed a lot of you the other day when you were evaluating your f of a plus h stuff, you forgot to put parentheses and therefore did not distribute. Please put parentheses around each f and g. That way when you make it a minus, you remember to distribute the minus. That's minus x plus 1. So please put parentheses around your functions. F times g. Who can tell me what we're going to be doing with this one? Yes. You have to FOIL it. That'll be 2x squared minus 2x plus 3x minus 3. And then when you're done, you just do your like terms, which are what in this case? right. Negative 2x and 3 add up to get what? Positive x. Very good. And that's f times g. Believe it or not, f divided by g is the easiest one. F divided by g is the easiest because you literally just stack them on top of each other, and unless something reduces, which won't often be the case, you're done. So f divided by g is literally f divided by, well, that's really sloppy, divided by g. Now, the only thing we haven't done for each of these is determine the domain, but we'll go back to that in a second. Nothing reduces on f divided by g, so that, and most of the time it won't. So that's done. All you do is stack them and you're finished most of the time. Now let's go back and look at these. Let's look at f plus g. Any problems with its domain? There's no radicals, there's no denominators. All reals. F minus g. Any problems with its domain? Nope. F times g. Nope. F divided by g. What is it? What's the problem? X can't be what? 1. So all reals except for x cannot be 1. Normally f divided by g will be your big problem. Unless, of course, one of your little baby functions you're doing it all with has a problem. Then usually they all do. But we'll look at that too. All right. For the first one that we've done, that's what you're going to need to do. Are there questions about any step that I took right there? Plus g minus g times g divided by g. Okay. Well, tell you what. Why don't you guys try this one? You guys try this one. I'm going to come around and take a look. Then we'll go over the answers, and then we'll do one of the harder ones at the bottom. No, you're doing the second one. We didn't do that one. Everything we did was that top one. So the 4 parts. Plus 2 minus 2 times 2 divided by 2. So you are working on the second one. You mean like factor?
I mean, like I ended up with x cubed minus 5.
X cubed minus 5x squared. So what happened to your 3? Oh, and you just divided it out? No, you can't do that. I mean, I guess you could have factored it out like this. Like you could have even taken the 3x squared out, but it sounds like you took out a 3. I mean, you could have done that. I mean, if you wanted to, there's really no point, but you can't just discard the 3. It has to stick around. That's, I mean, I like that you're thinking about that kind of stuff. And if there was a denominator, think something you might be able to, you know, cancel or something, then, you know, that might have helped you. But if there's not, then leave her alone. By Rod Stewart. Virginia? Nope, nobody. Any questions about any of the other parts? Yes, ma'am. Well, I did. See, I did x minus g. Well, technically there were parentheses, but since there was just one term, I just put this one in the front. I like to have mine in descending order, and that will be helpful to you if you get in the habit of that too, but it's not required. So if you had x minus 5 minus 3x squared, is that what you had? That's fine. That's perfectly fine. Any other questions? Well, if you're looking at this, you might be thinking, well, the last two look a little harder just because they have a radical and a denominator in them, but they're really going to be pretty much the exact same. Can I take this off the board? Is anybody still writing on this stuff? All right. Y'all want to look at, I'm going to call this, I don't think this is what these numbers are, but do you want to look at 45 or 47? 47 was the first thing I heard. Maybe we can go back to 45. So, f plus g. F plus g, 2 plus 1 over x plus 1 over x, like terms. You have two 1 over x's. When you add and subtract functions, what do you have to have? I mean, fractions. Common denominator, yeah. These two already have a common denominator, so we just need to add their numerators. So 2 plus 2 over x. What's the only restriction to its domain? Yeah, 0. That's the problem right there. F minus g. Same exact thing, except it's a minus sign this time. What is 1 over x minus 1 over x? Nothing. It goes away. So just 2. And there are no restrictions. F times g. 2 plus 1 over x times 1 over x. You can tell me what this is going to be. When you multiply fractions, what do you do? Yeah, you multiply across the top and across the bottom. So this is the same as over 1. So 2 times 1 over 1 times x. 2 times, 1 times 1 over x times x. And that's it. You literally take this piece and multiply the top and bottom of both of them individually. What are my restrictions? X cannot be 0, because that would give us 0 in the denominator. What about f over g? Ooh, a fraction over a fraction over a fraction. That isn't pretty. You can tell me what happens when you divide fractions. What's that the same thing as? Divided by a fraction is the same as flipping and multiplying. So you could rewrite that as 2 plus 1 over x times x over 1. And then it becomes just like up here. 2 times x over 1. X over x just becomes 1. And that has no restrictions. Now, I know we did some crazy algebra stuff right there, flipping and multiplying and all that jazz. Raise your hand if you have any question about anything we've just done on the board. Please do not hesitate if you have questions. Nope. $45 is actually going to be pretty much the exact same, except it's going to be even prettier because square root of x, okay, when you add and subtract, you're not going to really have to do anything because square root of x isn't common with anything. So you're just going to be listing all three terms, similar to this one. See how they just always kind of went next to each other, nothing ever combined? Same thing here. They're never going to combine. So now times might be a little tricky. Let's look at f times g and divided by g for number 45. Is anybody still writing what I have on the board? Okay. No problem. I'm just going to scroll down a little bit. And I'll start working it down here underneath the line. We're going to look at f times and divided by for number 45. So f times g, you know what? Let me get this out of your way. F times g will be radical x times x minus 4 Who thinks they can tell me what I need to do here? Here, you could get all fancy with your algebra and do some stuff here, but essentially you're going to have x times x, it's going to be this. When you just distribute, which you could then just factor right back to here. So there's really not a whole lot you can do. And if you wanted to get really fancy, if you're somebody who's really good at your algebra, which would be impressive, this would be x to the 3 halves. Actually, that's not even true. I'm not even going to get away with that. Let's just stop with that. Yeah, you can rewrite this like this if you want to, but if you leave it like this, undistributed, I wouldn't even mind. What are my restrictions for x on the domain, though? I'm sorry? X must be greater than or equal to 0. Right. F divided by G, so that's going to be radical x over x minus 4. Nothing we can do, but what's my restrictions? X cannot be 4, and x has to be greater than or equal to 0 still. Yeah. Questions? Okay. Raise your hand if you are still writing any of this stuff. All right. Skipping on ahead. Remember, I warned you on Friday this is a long lesson. Remember, this is just part 2, but it's going to be lengthy in and of itself. Compositions. Compositions. When you compose, which is what this little circle is, this is not a times. This little circle means you're going to compose, that's just the vocabulary word, G onto F. Okay? Here's what you do there. You literally evaluate one function at the other one. In fact, here's another way people write this that might help you even visualize it better. If I said f of 2, you'd plug in 2 for the x, wouldn't you? Well, a composition is just like this. You're going to plug in the second function into the first function. So f of g is going to be 2x plus 7, and then you can distribute. You literally plug the second function in for the x's on the first function. G of f of x, you're going to plug f into g. So that'll be 2x plus 7. Whereas this one would actually end up being 2x plus 14. This one is just 2x plus 7. We plug f into g for the x. Before I go on to part C, are there questions about where I'm getting these? Okay. F of g of 2, you just plug 2 in for f of g, which we've already found. So we're going to plug 2 in right here. So it'll be what? 2 times 9 equals 18. You just plug 2 in for the x on f of g, which we've already found. So it'll be 2 times 2 plus 9, which gives us 18. Questions? Let's just skip straight to a lengthier, harder one. The bottom one. Let's look at the bottom one. F of g. When you plug g into f, it'll be 4 minus, in fact, let me label this, f of g. So it'll be 4 minus 2x squared plus x plus 5. Who can tell me why it's important to put parentheses? Distribute the minus sign. That's going to end up being negative 2x squared minus x minus 5, which I like to write in descending order, minus 5 plus this 4. Make that a minus 1 when you're all said and done. Combine like terms. Positive 4 minus 5 gives you a minus 1. Oops, got my squared. What about g of f? Who can tell me? Somebody raise your hand and tell me how I'm going to plug f into g. Yep. Right, basically. So it'll be 4 minus x squared plus 4 minus x plus 5. How do I do this? keyword I'm looking for here? Yeah, well, when I square it, what's going to happen? What do I have to do with it? I have to FOIL it. Please do not say that that is 16 minus x squared. That will be incorrect. You have to FOIL it. So I'm going to write that right up here. 16 minus 4x minus 4x again will be minus 8x plus x squared. Now we can drop that parentheses because it's just a plus sign. Simplifying, combining like terms, that'll be 2x squared. Well, you know what, let me write it in order before I get all fancy. Is there a question? 32 minus 16x plus 2x squared plus 4 minus x plus 5. You have a whole lot of combining of like terms to do. I know. These problems can get a tad lengthy. Minus 16x minus 1x is minus 17x. 32 plus 4 is 36 plus 5 is 41 when you combine all your like terms. And that whole thing is g of f. That's as long as I can foresee it getting. I think. I don't think you have any. Well, there's two trinomials. Questions? Oh, and then you'd have to do f of g of 2. But remember, that just means you come in and plug 2 in for the f of g function, which I'm trusting you can, well, that'd be negative 2 times 2 squared minus 2 minus 1. Hey. Oh, right, thank you. Okay. Then you just solve this, and that'll be f of g of 2. So negative 8 minus 2 minus 1, negative 11. Any questions about anything you see before we keep going? A lot of different stuff we're doing today. Okay, so we've added, subtracted, multiplied, divided, and now composed functions. Man, the nice guy in me says we should just work on those. Maybe we can try one more slide. Oh, look, there's still compositions, so technically we are still working on those, like you asked for. Okay, these follow the exact same instructions as the last ones. We'll call this number 1, 2, and 3 for right now. If you want to look at those and raise your hand and say, I'd really like to see number whatever that would be, I'd be more than happy to work those. Yes, ma'am. Number 2, because of the fraction. Well, good idea. Let's look at number 2. First off, f of g. So 2 times. Now, what's going to be kind of neat about this, I'll go and warn you now, is the way things are going to cancel. And the book likes to get all cute with stuff like this, so you're going to notice this kind of thing is going to happen kind of often this year. Yeah, that's right. This is f of g for number 2. What kind of algebra magic is about to happen here? I turned up my volume, but I can't hear anybody. Yeah, a lot of stuff's going to cancel. The 2's are going to cancel. Times 2 divided by 2. Then you're going to be left with x plus 3, x minus 3. Those are going to cancel, and you are left with x. I know, that's neat. In fact, we're going to be learning something in the not too distant future where when you compose things and get x, there's something magical happening. But I'll tell you about that later. Okay, g of f. Same kind of thing. Plugging in f into g, so it'll be 2x. What am I doing? 2x minus 3 plus 3 over 2. What cancels? The 3's first, leaving you with 2x over 2. 2's cancel, and once again you're left with a magical x. F of G is going to be F of G of 2, if you remember, which was part C, is going to be really easy for this one. Plug in 2 for F of G, and it's just 2, because it's just an X. If you have a question about, if you're like, well, I didn't know you could cancel like that, or how do you know you'll be able to drop the parentheses, or if you have any of those kinds of questions, feel free to ask those as well. You're like, well, how are we going to know when to, or anything like that? No. No. Okay, that's cool. Let me just take a look. Oh, it's the same stuff. F of G, it's the exact same things we were just doing. The only difference is they just want you to find the domain of your composition, which you've already done. So like if we were to have done that for the last one, what's the domain of these two? All reals, yeah. All reals. So same thing, just after you do it, find the domain. Is there one on that page that is taunting you? Well, it looks like it goes to 72. I think we might stop at compositions, at least for now. We'll get into that fun. Oh, wait. This is an easy slide. Well, I was thinking there was other stuff on the slide. Oh, we can finish this. This isn't that bad. Are there any questions from what you see right here on the screen? Same exact stuff we were doing, except find the domain when you're done. Okay. Oh, dang it. I just need to take that little icon off my desktop. Go away. Okay. Express the given function as a composition of two functions. Don't reinvent the wheel here. Look, if I asked you, what's the parent function of this guy, what would you think? The first one. We'll call this 73. What's the parent function of the top one? X to the fourth. Yeah. So, let's call one of them. I'm almost afraid that anything I say is going to be kind of overcomplicating this, because this is such a simple thing, if you can see it. You see how, in fact, let me just show you the answer to the first one, and I bet you'll be like, oh, I see what you did there. Here's an example of one of these. You see how if we compose G into F and just plugged it in right there, you'd get 3x minus 1 to the fourth. They're just wanting you to see that these functions are kind of just combinations of functions if you want to look at it like that. So like here, what do you think your f of x is going to be on this one? What do you think the thing you're plugging into is going to be? The cube root of x. And what are you plugging into the cube root of x? X squared minus 9. What's our f of x here? Absolute value of x. What are you plugging into it? 2x minus 5. 1 over x. Okay. Now I know the same people were doing all the talking there, so I'm kind of letting 5 people speak for the trees. That's a Lorax reference. Does anybody want to raise your hand? Don't feel hesitant and say, I don't see where they're getting me. Okay. Last one. These are actually kind of fun. 89. F of G of negative 1. Well, here's what since you don't have functions, here's what you kind of have to do. You're going to plug the negative 1 into the G, and then plug that into the F. So, if you start out looking at G of X, what is G of negative 1? You go to negative 1, what's my Y value? Negative 3. So I'm going to plug negative 3 into the F. What is F of negative 3? Positive 1. That's how those work. Look at 91 and see if you can't figure out what that one's going to be, and then I'll say it. when you think you know it. Give me one of these. Seamus. Let's see. F of 0 is 2. G. Dang it, I did it backwards. No, I did it right because it says G of F. F of 0 is 2. G of 2 is negative 6. Good job. Notice the order changed here, so that's why we started with the blue one and the purple one. Good catch. Questions? You got 91 but not 89, or do you want me to just explain? Oh, just start with 89? Okay, sure. First thing, if I just asked you to look at this and say, where is G of negative 1? You'd find G, which is the purple one. You'd go to negative 1, and you'd find the Y value, which was negative 3. So that's what you've done with this step. So now, you're basically going to take F of that, which was negative 3. So now we're essentially taking F of negative 3, positive 1 on the f of x function, and that's where that came from. We good? Any other questions? Good question. All right. Now, I believe the other day we went through number 30. So there we go.